Welcome everyone again to another episode of the ideaXme show, the show that profiles the humans behind the big ideas that shape our world and inspire the future and future creators, and for all those that like great stories. I'm Ira Pastor, your life sciences ambassador today. Today we are honored to be joined by Professor Dr. Hiroshi Ishiguro, who is Director of the Intelligent Robotics Laboratory of the Department of Systems Innovation in the Graduate School of Engineering Sciences at Osaka University in Japan. Professor Ishiguro is also director of the Advanced Telecommunications Research Institute, which is a private company that's supported by industry, government, and academia with the aim of promoting fundamental and innovative R&D activities, as well as contributing to society in a range of telecommunications fields, and is active there in fields including neuroscience and knowledge science, intelligent robotics, machine language translation, and wireless communication. Professor Ishiguro is also Chief Technology Advisor to Vstone, which is a commercialization technology transfer organization surrounding his inventions. Professor Ishiguro's lab works at the intersection of computer vision, robotics, artificial intelligence, ultimately concentrating with the idea of making a robot that is as similar as possible to a live human, and ultimately believes it will be possible to build an android one day that's indistinguishable from a human. Professor Ishiguro has a PhD in robotics and computer sciences from Osaka University, has attended Yamanishi, Kyoto, and Wakayama University and University of California, where he has worked on a variety of related disciplines, including sensor systems and interactive robotics. Professor Ishiguro, thank you for taking the time to come on the show today.
Welcome.
So yeah, we typically start off by giving our guests the floor just to have them talk about a little bit about themselves, a little about your background, where you grew up, how you got interested in both computer sciences and robotics, and this fascinating interest in sort of the merging of all of these themes together into a very human robot system.
Yeah, my background is basically the computer science. When I have studied computer science, I was interested in artificial intelligence. Then I thought the artificial intelligence needs a body. Embodiment is important. Then, I studied robotics. When I have studied the robotics, I was thinking, what is the ideal robot for the human, especially for the interaction with humans? So I thought the human-like robot probably is better than the other robot for the human-robot interactions, because our brain has a many function to recognize humans. So therefore, I have decided to create a very human-like robot, Android. And, right now I'm running the Android project, and maybe I will say the surrogate avatar project. So now we have a serious problem with coronavirus, but if we have a teleoperated robots, surrogate or avatars, that we can stay at home, but we can work outside in companies, and, we can do something in universities, right? So I want to create that kind of a futures. The one more thing is, basically, my dream was to be an artist and oil painter. I just gave up to be oil painters, but I think I'm doing similar things with the robots. So the purpose of an oil painter or artist is to represent the humanity on the campus. But I'm trying to understand humanity and represent the humanity on the robots. So probably I'm doing the same things. And I would say my basic interest is what human is. So that is the most important motivation for me.
Wonderful, wonderful. There's a quote from you on your website where you talk about sort of, where you're coming to the end of the information age and the beginning of this robot age. And, unlike what we see in the movies where in the future we have humans and then some robots walking down the street, you're of the position that these two areas, IT and robotics, they're going to fuse together. So it's highly unlikely that we will even notice, unless we really pay attention to it, that this is a robot one day. And then you say how our brains, as you just mentioned, we're wired for human to human, human to mechanical robot, as that thing we think in the movies, not so much. How does our brain, can you sort of, without going into the depths of the neuroscience, how does our brain sort of, in what you've studied, work or think differently when we see that mechanical Hollywood thing that is called a robot
Mhm.
versus when we see a flesh and blood person?
Well, I think there is a famous psychological phenomena, the uncanny values, right? When we see right a mechanical looking robot, but somehow this human like a Terminators,
Yep.
that is quite uncanny for us, right? But when we see the very human-like robot, we can naturally accept. But the important things, the human-like robot need to have the human-like modalities. The
Okay.
human-like robot need to have human-like face appearance and well, the conversational abilities and the movement. Everything need to be human-like. But if one of the the modality is not human-like, it looks like a scary robot and zombies or Terminators, right? So I think that is the difference, right? The humans, we cannot accept the uncanny robot, but if a robot, the human-like enoughly, we can accept the robots as a kind of a humans, and then we can naturally interact with very human-like robots.
Wonderful, wonderful.
Mm.
So, you have a wide range of projects going on, both at the university and ATR. And I have a few of them outlined here, and I just thought these would be interesting to go into just a little bit to show the scope of what you're doing. And I'd like to start off with Geminoid, which is a tele-operated android. It's has the appearance of a person, you in this case, because you modeled it after yourself. And in this particular program, you're investigating the ability of how this android can socially influence a person, and at the same time, you're exploring these concepts of the very basics of how conversation may be different or affected when we interact with a robot or an android. Talk a little bit about this sort of projects, and these are one of the
All
base
right.
programs that you created.
Right. I think the Geminoid project is very important for me. It was a kind of the big challenge as in robotics, and I had two purposes. One
Okay.
is practical purpose. Of course, the practical purpose is to use the Geminoid. Instead of me in a lecture. So for example, I can send the Geminoid to the foreign countries or other universities, and I can give lectures by teleoperating a Geminoid, right? And so that means I can exist in two places simultaneously.
Mm-hmm.
So this is the very futuristic technologies, but I believe we need this kind of technologies, right? Especially for solving our current coronavirus problems.
Sure.
So if you have a chance, I recommend you watch the movies. The title,
Yep.
The Surrogate. I appears in the beginning of the movies, and then the main story is in the starts, and the main actor is Bruce Willis.
Mm-hmm.
The story itself is a little bit extreme stories, but that is a kind of a possibility in our futures. So then, another important thing is not to develop the more human-like robots. So we need to deeply understand what human is. So Geminoid, there can be a test bed for understanding the humanities. We can directly compare the Geminoid and myself, and we can find the many the important factors for the human-robot interactions and important things for making the robots more human-like. So, we have two important aspects for the, Geminoid project, and still we are continuing that, the projects, those projects, and for investigating it, for improving the technologies.
Got it. Got it. Another, very interesting one, especially we talk on the show a lot about mental health and psychology. You have the Become You project, specifically focusing, in this case, on supporting people with autism spectrum disorder, which we discussed a little bit. It's a severe disability in children that can have social, communication, behavioral challenges. I think the number here in the U.S. is about 1 in 50 children. And you've discovered very interestingly that robots, in this particular case, can serve as a very important bridge between what someone with an autism spectrum disorder and their caregiver might not have. And you've just, found out that children may disclose things to a robot differently or more easily than they would a caregiver directly. This is quite fascinating, in my opinion. Can you talk a little bit about what you've learned on this front?
Yes, that is also the very important research project for us, right? So we are creating a very human-like robot, but at the same time, we are creating the more animation character-like, the robots.
Yep.
It's more simple robots, and actually the autism kids like to interact with the animation character-like robots, but they don't like to interact with very human-like robots. They are feeling some pressures from a human-like appearance, but they don't feel any pressure when they interact with animation character-like robots.
Mm-hmm.
And actually our collaborators, he is a medical doctor. He is running the autism kids hospital. Mm-hmm. And he is using our robots for communicating with autism kids. So autism kids, right? They cannot talk to the medical doctors, nurse. They cannot talk to the very human-like robot, but they can talk to the robots. So medical doctor is operating the small, cute robot and talking with autism kids and gathering the, a lot of conversation data for the diagnosis, right? So that is very useful. And the autism kids, and then everybody surprising, especially the parents, right? And the parents is actually parents and the autism kids are very happy with the robot and the conversations through the robots, and so we are running this kind of project more than 5 years, and we are they're getting a lot of knowledge and the know-how. Mm-hmm. How to deal with the autism kids and how to treat, right? I think a robot will be a very important research tools for autism, and a kind of a medical device. Mm-hmm. For improving their problems, right? And then maybe the one more thing is elderlies. So elderly, they also have similar problems, right? They don't like to talk with a very human-like robot or humans, but they love talk with the simple, right? And that robot looks like a kind of humans, but it is not so complicated, right? So it's a kind of minimal design of humans. So elderlies, they love to talk with that robot. Mm-hmm. So I think elderlies and especially for the dementia people,
sure,
and autism kids, they're kind of similar, and that they accept the robots very much. So robots can bridge, the ordinary people and the people who have the problems like dementias and the autism.
That's very interesting. And we've actually recently talked about one of the things we don't think about with the elderly is just the concept of loneliness, and that if a robot can serve as an intermediary there, that's another wonderful possibility. Continuing along this this theme, one area that we have discussed a little bit on the show recently is that of brain-machine interfaces.
Right.
And now in your particular case, you're going sort of that next step where we're talking not just brain to a computer, but brain to an actual robot and moving that robot around to do things. And you talk about this very interesting phenomena that you've worked with or discovered called body ownership transfer, which is this really unique, it's hard to wrap my round about it, but a phenomena where through a brain-machine interface, the operator actually feels like the robot is part of their body. And this, this obviously, once again, there's a lot of science fiction things that come out of Hollywood, but sort of this whole avatar and so forth. Take us a little bit down this path, because this is truly
this is not scientific fiction. It's a real
yeah.
things, right? So, as I said, I have developed the Geminoid system. Geminoid system is a teleoperated robots, right? So, and we are developing several types of in the interface, the brain-machine interface and the normal interface. Both the brain-machine interface and normal interface, the based on the cameras and the microphones. Well, we can have a body ownership transfers in both cases, right? And of course, in the brain-machine interface, we can have a very strong body ownership transfers, but informations, they're controlled by, that we cannot get enough information from the brain scanning the systems, and we have some limitation for the robot control. But if we use the normal interface like cameras and the microphones and some sort of a computer interface, so we can they fully control the robots. So. And the brain, if we have a more sophisticated brain machine interface, of course, right? So we can completely accept the Android body as our own bodies. But even if we use a simple brain machine interface or normal the computer interface, we can accept the Android body as our own bodies. Okay. So that is a very, very important, right? So as I said, I can use my Android for giving lectures in foreign countries, right? If eventually one of the students touch to the Android bodies, I can have some feeling to be touched, right? So mentally, I can exist in a distant place. Okay, so this is the most important possibility of a teleoperated system. Okay, so the reason is our brain is not tightly coupled with the bodies. Okay, so connection between the brain and the body is the quite sparse.
Sure.
So therefore, we can easily replace the body with the Android bodies if we understand Android is moving and interacting with others based on my intentions. Right? So that is the important things. So now we are developing the more better systems, right? So now I'm talking, right? So if we gather my talk, and if computer analyze my conversations, the computer may understand my intentions. Then the computer autonomously control the robots and the teleoperated robots. So that kind of more intelligent systems, they enable the more flexible and the more strong, flexible teleoperations, and then we can have more strong body ownership transfers. Really? So unfortunately, I think we cannot develop the sophisticated brain-machine interface, especially in Japan, right? If we can put the electrode in the brain directly, of course, we can have a more sophisticated control. So that system is not is not possible in Japan, but maybe in the United States. For example, Neuralink, they may develop a kind of a kind of storage, the brain-machine interface, right? But I think we can take another approach, right? So we're gonna use the artificial intelligence for controlling the robots, and then artificial intelligent system read my mind and operate the robots autonomously. So and then I can have a kind of the more autonomous teleoperated robot. So this is not completely autonomous robot. Right. So important things is the avatars or teleoperated robot need to follow my intentions.
Right.
Okay? The fully autonomous robot can have their own intentions. But if avatars, they can read my intentions and behaves based on my intentions. So that avatar is going to be my bodies. So I want to develop that kind of a system in a very near future.
Fascinating. Fascinating. What, at the beginning, Alicia, you obviously mentioned your interest, you have a broad set of interests, but you were interested in the arts early on, and you do have a program within the portfolio called the Robot Performing Arts Program, where you talk about sort of advanced artworks and social implementation, collaboration, and so forth. And the concept of a robot theater project, where robots are performers of complex theatrical work. Obviously, before the pandemic, we went to Disney, where they have plenty of audio animatronic stuff around. Is the concept here that somebody would actually be able to see a theatrical presentation and not know ahead of time that those are not automatronic? So tell a little bit about your thoughts on this one.
Actually, the theater activity is also very important for us, sure. Right? So in order to create the human-like robots, so we didn't have enough knowledge about the human behaviors. Which behavior is a human-like? So we have investigated, the psychologies, the studies on the psychologists or cognitive science, but we couldn't find enough knowledge, that explain how to behave in daily situations, how the human behaves human-like ways in the daily situations. Daily situations are so complicated. Neuroscience, cognitive science, and the psychologists, they are always using a well-controlled environment. They're studying the human behavior in a very, very simple, the laboratory environment. It is not daily environment. In a daily situation, we have many things, right? So many people are talking, and we need to interact with so many people, right? But in order to create very human-like robot behaviors, right? So we need to consider how the robot behaves in a daily situation, in a more natural environment, right? So that is the first problem. And the second problem is, what is the conversations? We didn't have enough knowledge about the conversations. So, what is the purpose of a conversations, right? So we have many purpose of, the conversations, and we can, talk with Alexas or some Google Home, sure. Right? But it is not, the human-like conversations, right? We want to talk under many things,
right?
But what is the purpose, right? So Orida Hirata, he is a very famous theater director, right? He's also studying the psychology and social psychology, right? And maybe cognitive science. And he has a lot of knowledge, and the direction is very, very precise, And actually, he knows, how the actor and actress can behave like naturally in daily situations, and he knows what is the conversations. Okay, so he is an artist, but he has the answers for my questions, right? Therefore, I studied about the theaters. And then I worked with Orisa Hiratas, and we have created the robot theater and Android theaters. At the same times, we learned his directions a lot, and based on his direction, we have developed the computer program for controlling the robots. Right, and then we are writing the many technical papers, right? So the art is a kind of a hint. For improving robots, right? The artistic idea is very, very important as the creator of a robot, So we are getting, and as I said, I wanted to be an artist. Therefore, I understand the importance of art. Art, does not need to have any reason to find some new ideas, right? The scientific approach, analytical approach, always, that's based on a kind of a framework, a kind of a knowledge, right? But if we wanna define the really new things,
Yep.
there is no hint in the previous science. Okay, so based on the intuitions, we need to find something. Okay, I believe artistic work, artistic mind can give us that kind of hints, inspirations.
Sure.
And then that we can we can solve the new problems, unknown problems based on the artistic mind. That is the reason why I'm working with artists and theater directors. That is why I'm interested in theater itself.
Right.
In the theaters, they are representing the humanities, human-like conversations, human-like, the daily scenes, right? I guess you could understand what.
Absolutely, absolutely. It's a fascinating what we'll convergence of these of these different skills to ultimately achieve.
Human is so complicated.
Oh yeah.
So that but we have so many activities about the humanities.
Yep.
Right? The theater activities are one of the very important activities. That is the reason why people are interested in the theaters, right? The dramas and the movies, right? We are also interested in that. Absolutely. And we are getting a lot of hints from that.
Thinking about this, there's obviously this Turing test concept of how, one would determine whether a computer one day is capable of substituting or thinking like a human being. Is there an Ishiguro test that needs to be the hurdle at some point in the future where that android fools a certain amount of people to at that point where we have that perfect android that I am unable to distinguish? Is there a framework for an Ishiguro test one day that one will have to go to achieve the equivalent of Turing test?
All right, we are proposing the kind of extended Turing test that is a multimodal Turing test. So the final Turing test is called the total Turing test. Total Turing test means we cannot distinguish the robots and the humans, right? And through all modalities. But even if it is not so human-like, we can interact with the intelligent robots. Okay. So we don't usually we don't care so much about the appearance. If the robot has 2 eyes and a mouth and ears, so we can naturally interact with the robots like autism kids and elderlies. Okay. So the cartoon character like appearance is also enough as the conversational partners. Okay. So and the important thing is, the challenge is if we cannot distinguish, this robot is operated by computers or this robot is operated by human operators. If we cannot distinguish the teleoperated robots and fully autonomous robots, and then we can say that the robot can pass the multimodal Turing test. Okay. So now we are preparing the test. Now we are discussing there are so many ways for designing the test itself, right? We cannot use the same approach to the as the Turing test. Turing test is it's the chat-based test, right? And they are exchanging their chat. And if we cannot distinguish, the computer is generating the sentence or human is typing the sentence. If we cannot distinguish which is which, so that means the computer can pass the Turing test. Right. But in our case, we have robots, right? So we have there are so many channels for the conversations, facial expressions, gazing, eye movements and behaviors, gestures, right? And the talks, right? So we need to evaluate through all modalities. Now we are, carefully designing the test, the multimodal Turing test, and we are maybe within a couple of months, I hope we can get that kind of a result for that. maybe the the initial result. But the so far we are getting the very good or response from the subject. We have we are creating a very human-like robots called Erika. I think
Okay.
you can check the Erika's movies on YouTube.
Yep.
Right? And that is a fully autonomous Android. Erika can talk with the visitors, maybe 5 minutes or 10 minutes, if in the scene of a first contact. So we need to limit the our conversational scenes and as the first contact, because Erika cannot have a deep conversations, but
Right.
Erika can talk about the weather and some but just simple things, right? So but many people they said, I thought, oh, this robot is teleoperated by a human. Right? Actually, Erika is a fully autonomous robot.
Okay.
But there's some of the subject and they were thinking, this robot was teleoperated by humans. Okay, that means they couldn't distinguish teleoperated robot and fully autonomous robot, right?
Yeah.
So that means the Erika the Erika has the possibility to pass the multimodal Turing test.
Wow.
So that is a kind of a goal of a current project.
Typically, the end of our show, we come back to our guest and really just ask a broad question about the important influencer mentors in your career to date that have sort of guided you on this path. Obviously, you no doubt have met many fascinating people, both in the sciences and the humanities, but any specific individuals you might want to mention at this point that have really been instrumental in your continuing?
I think I was very lucky, my professor when I was the student, and when I was the young researchers, I met the two important professors, Professor Tsuji and Professor Ishida. And Professor Tsuji said, okay, think about the fundamental issues, right? Don't think about the, some simple things, but always think about the fundamental issues. So my answer was what human is. That was the most important things for me, and I could recognize what is the most important things for me, right? And then Professor Ishida, he said, okay, so don't write the technical paper so much, right? So most important things is to change this world. Okay, right. Do the research to change this world. That was his mission, his comments, right? And then I have decided to create more impressive things, more human-like robots, Android, right? And both professors gave me a very important comment. And then maybe in addition to that, Alan Kate, he's father of personal computers, and the Alan Kate.
Okay.
He's the father of a personal computer. He was working in Apple.
Okay.
Maybe there's Silicon Valley, right? And he was a very famous guy anyway. And when I talked with Alan, I asked, so do you think you are the creator of a personal computers, you have created this information societies, but how about the robot society? Do you think we're going to have a robot society in the future? So that was my questions. But he said, you are creators, right? You should create your own, you should create that kind of future by yourself, right? That was his mission, his comment about my questions. And after meeting, after having the conversation with him, I always said, talking about the my intentions, my dreams, what I want to do is, I want to create the robot society in the futures. So that is my mission.
Wonderful.
So I think, I have three important people.
Very, very elegant message, and really wishing you the best with it and continued success in the area. For everybody that's going to be listening to the podcast or watching on video, you've been spending time with the amazing Professor Dr. Hiroshi Ishiguro, Director of the Intelligent Robotics Laboratory at Osaka University, Director of the Advanced Telecommunications Research Institute, Chief Technology Advisor to Vstone, doing amazing work to for the transition between the information age and the robotic age and usher in the robotic society. Professor Ishiguro, thank you for taking the time out of your schedule to come on the show. As we say, thank you for moving the human story forward, in this case, moving the robot and human story forward. It's really, truly amazing work that you've done. Really impressive.
Yeah, thank you very much.